Bismillahirrahmanirrahim. Let's reinforce our learning by using a numerical problem. The figure is given. The mesh shown is that of an axisymmetric finite element model, and we are required to compute the K for element 1. And two types of pressure are given: vertical pressure on the top and the horizontal pressure on the side wall. And we are supposed to convert these into the nodal force values. Let's start with the computation of K, and for K we'll need B. First of all, let's draw this element 1. We're talking about element 1 here, and the nodes are 2, 1, and 12. The main thing is that we need to specify ijk nodes, and counterclockwise, it doesn't matter where we start, we go counterclockwise. The I node, let's call this node 2 as I. This coordinates are 6 and 6. Then this J node will become node number 1. It's 4 and 6 coordinates, and K node will have coordinates of 6 and 4. And again, this is R, this is Z, as shown on the figure also. Now the B matrix, which is necessary for K, is this. We call from the previous lecture 1 over 2A, BI0, BJ0, BK0, 2A NI over R0, 2A NJ over R0, 2A NK over R0, and then you have 0 CI, 0 CJ, 0 CK, and CI BI, CJ BJ, CK BP. You need to calculate all these in order to find B, and then from B to K is a simple matter. Recall that for plane stress plane strain, Bi was simply 1 1 Yj Yk. Similarly, Bj Bk also, and Ci was Xj Xk 1 1. Now, only thing we have changed from plane stress plane strain to axisymmetric is now X has become R and Y has become Z. That is all. So if that adjustment is done, then Bi will be nothing but 1 1 Zj Zk, and Bj 1 1 Zk Zi. Ijk must be in sequence. Similarly, Bk minus 1 Zi Zj. And if we put in the values 1 1, we have the values on the diagram 6 4. Here we have 1 1 4 6, and here 1 1 and 6 6. 4 minus 6, this is 2, minus 6 minus 4, this is minus 2, 6 minus 6, this is 2. Add all these together, it turns out to be 0, which is a good indication that we are doing it correctly. Now we come to C's. Ci will be minus Rj Rk 1 1, Cj is equal to minus Rk Ri and 1 1 here, and Ck is equal to minus Ri Rj11. Values you can see from the diagram. Minus sign 4611. Here we have 6611, and here Ri and Rj we have 6411. Let's calculate these two. Minus 4 minus 6 equal to 2, minus 6 equals 0, and here we have 6 minus 4 equal to minus 2. Again you add them together and you get 0. So it's a good start. Now we move on to the other values that we need. What we need is now 2a, ni and r. Let's start with 2a. Area of a triangle is equal to half into base into height. Now for this element we have height and base both equal to 2. We are not interested in a but rather in 2a, so this is simply b into h, which implies that 2a is equal to 2 into 2, 4 square millimeter. Now ni, nj, nk and r values. Now ni, nj is equal to nk. By definition they are all 1/3 because we are talking about the centroid. Now r at the centroid is ri plus rj plus rk over 3, and Ri, Rj and Rk are 6, 4 and 6 respectively. 6 plus 4 plus 6 is equal to 16/3 millimeters. So we have all these values with us. All we need to do now is put in the values in their respective places. Now 2a 4, bi 2, 0, bj minus 2, 0 and the others are 0. Maybe it's a better idea to first calculate the values of 2a ni over r is equal, and which happens to be the same. All three values are the same because ni, nj, nk, they are all the same values. It's simply 2a 4, ni, nj, nk 1/3, and r was 16/3. Just calculate it. So actually these all three quantities, they turn out to be 1/4. So we can just put in the values 1/4, 0, 1/4, 0, 1/4, 0. Rest is ci, cj, ck are 2, 0, minus 2, 2, 0, minus 2, and here we have 2, 2, 0, minus 2, minus 2, 0. Or if we prefer, we can write this as 0.50 minus 0.5000. And we have 0.0625, 0.0625, 0.6250. Here we have 0.5, 0, 0, 0, minus 0.5, and here 0.5, 0.5, 0, minus 0.5, minus 0.5 and 0. So this is the value of B calculated at the centroid. Now the next step is to calculate K, which is simple but tedious because it involves a product of matrices. But first start with the formula from the last lecture. Recall that this is how we calculate the K matrix. Now all these values are, all these quantities are known, so there's nothing difficult about it. So these things are left best to Excel or some other software. Now this B transpose matrix, this B is 4 into 6, but this B transpose matrix will be 6 into 4, obviously. D is 4 into 4, you know this. Please recall the last lecture. B will be 4 into 6. So when you multiply them all together, you should get something like 6 into 6, which should be the case because you have 6 degrees of freedom. So that makes sense. And the next thing is about the units. The units for B matrix are, if you, the BI, BJ, BK, all these values, they are in millimeters. And 1 over 2a, this is in millimeter square. So 1 over millimeter is the unit of this matrix. This is 1 over millimeter. Now D matrix, this is Newton per millimeter square, or at least this is what you should convert it to if you are using the millimeter system. And then again 1 over millimeter. As for R, it is in millimeter, and area is millimeter square. So what you get is this millimeter square gets cancelled with this, and this millimeter gets cancelled with this. So for K, you are left with Newton per millimeter, which is exactly the value, the unit that you should have got. Because ultimately K U is equal to F, and this is in millimeters and this is in newtons. So this is the only way this is going to work. Now let's focus on the second part of the problem. We need to convert the pressures. There are two pressures given: 10 Newton millimeter, 10 Newton per square millimeter, and 5 Newton per square millimeter. So let's convert them to modal forces. So first of all, let's take element 1. This is element number 1. And let's call this I node, this column J node, and this is K node. For this, only nodes I and J are relevant here. So recall the expression FP IH IJ over 3 2RI plus RJ PR 2RI plus RJ PZ RI plus 2RJ PR RI plus 2RJ PZ and 0 and 0 for the K node. Now this is I into this length, H length is, we were talking about this length here. This is 2 over 3. Now PR is 0 in this case. This is the pressure on element 1 is Z direction. This is 0 as for the second line. So this whole thing becomes 0. The second line, 2 into RI is 6 plus RJ is 4. 2 plus 6 into 4. 2 into 6 plus 4 into PZ is minus 10. This is in the negative direction. Similarly, the next one 0 again. Now Ri plus 2Rj. Now this is 6 plus 2 into 4. Now again into minus 10, and then you have 0 and 0. So if you calculate, then you get 0 minus 335, 0 minus 293, 0, 0. Now come to element 2. Similarly, calling this I and j node in the same scheme, that is, for element 1 it was node 2 and 1, that were important. For element 2, the I and j nodes will be 3 and 2 respectively. So again, using the same scheme, here this is element 1, so you could differentiate between the elements. Now again, the same equation, so I'm not going to write the equation again. Pi into length is again 2 over 3, this is the same. Similarly, r values are 0, but here 2 into 8 plus 6. Now we're talking about the next element, into minus 10, again 0. Now 8 plus 2 into 6 into minus 10, and then 0 and then 0. So this gives you 0 minus 461, 0 minus 419, 0 and 0. This is element 2 taken care of. Now we see element number 3. And this time again I and j, the nodes will be 4 and 3. Coordinates are given in the diagram. So FP3 is pi into 2, length is again the same, 3, 0, 2 into 10 plus 8 into minus 10, 0, 10 plus 2 into 8 into minus 10, 0, 0, and this gives us minus 586, 0, minus 545, 0, 0. And these are all in newtons, these forces. So let's plot these forces on the diagram, because this is what we were required to do, convert the pressure into nodal forces. So this 335 and 293 comes here, 335 Newton, 293 Newton. For element 2, 461 and 419. 461 Newton and 419 will be superimposed on that from element 1. And element 3, 586 and 545. And obviously on 2 and 3 it will get added, the two values will get added, and if we go on to other elements here, then we will then have to add here also. So this is how you convert the pressure forces into nodal forces, because recall that in FEM we can only apply nodal forces, whether it's body force, force due to temperature change, pressure force, we have to convert those into nodal values, and what that we have done already here. So that takes care of the 10 MPa pressure. Now let's see the 5 megapascal pressure. This one. Now this is vertical. The pressure is acting on different elements, but the relevant sides of the elements, they are vertical. If that is the case, then obviously We'll be modeling this like this. This is I node and this is J node. Let's call this element 11. And obviously there's a K node also here. That is irrelevant because the pressure is only being applied on the IJ node. So because this Ri is equal to Rj is equal to R in this case, which is 4 millimeters, we can use the simpler of the two formulas. Recall the last lecture, and for the 11th element, the pressure force will be, the formula, the simple one is pi R H I J P R P Z P R P Z 0 and 0. Now in this case, pi R is 4, length of each element side is 2 into, now in this case radial pressure is 5, whereas the longitudinal one is 0 in this case, 5 0 0 0, and this turns out to be 126 0, then 126 0 0 0, again in newtons. Now if you consider this diagram, the element 31 is the same because all the dimensions are the same. So this also is the value of, this is element 11 and element 31 is the same. So if we are to plot these values, nodal values, you have 126 newtons, 126 newton. This is element 11. When it comes to element 31, again the same values. So here you get superimposed on the first one, and then you have 126 newtons here. And if you are going to go in this direction, then maybe you have to add on the values. So this brings us to the end of this problem. Now we'll just finish with one interesting point, and that is, if we focus on element 2 here, this one, let's try and calculate the value of forces that are generated as a result of pressure on element 2 alone. Recall that the real problem is a cylinder. The problem is a cylinder, and we have this kind of a situation. This is the center, and the cylinder is something like this. Obviously there's a length here, and all this top surface is under constant pressure Pz, which is actually negative downwards. Now when we talk about element 2, actually what we are talking about is, this is the IJ value, I and J nodes, but actually what is happening is element 2 corresponds to the whole 360-degree area between node I and node J. So if we are going to calculate the force generated because pressure on this element, then we need to see this whole area, because the pressure is being applied on the whole top surface. But when we talk about element 2 only, then force generated as a result of that pressure will be this area, corresponding to element number 2. Now the pressure is 10 MPa, and this area is I into, if we look at the diagram, element 2 we are talking about this is what we're talking about here. So the radius is from 6 to 8. So the area we're talking about is 8 square minus 6 square. This is the area. Now the force will be this pressure into area, I into 8 square minus 6 square into 10, which is 880. Now this is the force generated by this pressure between the I and J node around the 360 degrees, because that is the total area which is the recipient of this pressure. So we have to distribute this force 880 into the node I and J. Now let's see what we have actually done as a result of our formulas. What we have done is we have, as a result of element 2, we have applied force of 419 Newton and 461 Newtons. These two forces, 419 and 461, on nodes 2 and 3. And if we see 419 plus 461, this is exactly equal to 880 Newtons. So we have applied the correct amount of force. Now, obviously, we have not applied this force equally. We have not applied on the I and J nodes 440 and 440. We have applied higher value on the on node 3, which is farther away from the center, and lower value on node 2, and that comes from the formulas which have their basis in mathematics. But physically also, the farther you move away from the center, there's more area there. So the node I in this case should be given higher value of force. But the force on node I and J added up, it becomes 880 as it should be. And this phenomenon that you apply higher value of force to nodes which are further away, this is not just peculiar to pressure, this is also applicable to volumes, to body forces, because not only the area becomes bigger and bigger as you move away from the center, the volumes also become higher. Thank you.